So we're going to do linear equations in two variables. I'm going to let A, B, and C be constant, so just numbers, where A and B are not both 0, so maybe one is 0 or the other, but both of them can't be. Then standard form is going to be written as A times X plus B times Y equal to C, okay? So where A, B, and C are integers, all right? So no fractions, but they're integers. That's the standard form there, okay? So first thing I want to do, I want to determine if the following equations are linear. So if you're asked on an exam to figure out if a equation is linear or not, if you can put it into standard form, then it is a linear equation. So that's how we verify. So my first example is 3x plus 2 parentheses x minus 4y equals 2x minus y. Now right now this is not in the form ax plus by equal to c. But we can do that by distributing. So I'm going to distribute here. So I have 3x plus, now this is 2x. And then 2 times negative 4 is negative 8. Y equals 2x minus y. Now look, I've got x's and y's all over the board. In standard form, I have just one group of x here and one group of y here. They're both on the same side. And then any numbers are left on the other side. Well, let's move everything over. Okay, so move this minus 2x minus 2x minus 2x minus 2x plus y. Okay, so, what's going on here? I have a plus 3x plus 2x minus 2x. Those cancel. And then I have minus 8y plus y. That's a negative 7y. And then a 3x. Equals, well, what is it equal to? That's 0 on the right side. Is 0 a number? Sure is. Is this an integer times x plus an integer times y equals an integer? Very close. I would accept this as an answer, but homework might say 3x plus a negative 7y equals 0. So maybe they get really picky. I would be cool with that, but maybe this is what they're looking for. Okay, so yes, it is linear because we can put it into standard form. Let's try another example. 9x squared minus x plus 1 quantity squared equals y minus 3. Okay. All right, now x plus 1 quantity squared, that's x plus 1 times x plus 1. When in doubt, write it out. Multiply through, I get x squared, and then times 1 plus x, or 1 and x gets me x, and then 1 and x makes me x, and then 1 and 1 makes 1. So all of that is subtracted. Okay. So then I have 9x squared, and then this is what? That's 2x in there. So I have negative x squared, negative 2x, negative 1 if I distribute the negative to each piece. Okay? Equals y minus 3. Combine like terms, I can combine these two here. That gets me 8x squared minus 2x minus 1 equals y minus 3. Now remember, to be linear, it needs to be ax plus by equals c. So let's get all our variables on one side. So I'm going to minus y. So I have 8x squared minus 2x minus y. Now that constant right here, I need to move that. So I'm going to add it to the other side. So negative 3 and 1 make negative 2. So look, I'm very close to, I have an AX, I have an AX, I have a BY, I have a BY, and I have a C, and I have a C. But what's my problem? The problem is this 8x squared. That squared is non-linear. Okay? So this is non-linear here. So no, it is not linear. It fails to meet the criteria. Okay? So that's kind of how it works. Let's do one more. 8 minus 4xy equals x minus 2y. So when I try to get my standard form, ax plus by equals c, we'll move all my variables to one side. So let's do this. Let's minus x and plus 2y. Minus x and plus 2y gets me 8 minus x plus 2y minus 4xy equals 0. We'll subtract 8 from both sides. So I get minus x plus 2y minus 4xy equals negative 8. Well, guess what? We're running into the same scenario again. I have my ax plus by equals c. Well, look, there's my ax, there's my by. Okay, that should be a y there, not an x. But then, and there's my c. But what do I do with this? That's nonlinear. Okay, nonlinear. So this one again is not a linear equation, therefore it's nonlinear. Okay.